Centaur is now 2/3 of the way through its 30-minute coast period. Continues to roll at -3 degrees per second in its PTC attitude. RCS continues to operate at 25% duty cycle. All Centaur systems are operating nominally at this point in the flight. Telemetry data quality continues to look pretty good with some minor interruptions. In about 30 seconds, we expect to see Centaur begin its turn to MES 2 attitude and begin 50% duty cycles on the RCS. And Centaur has begun to reorient to the MES 2 attitude, and RCS is now operating at a 50% duty cycle in preparation for MES 2. 5 minutes to MES 2. We are experiencing some data dropouts associated with the PTC roll and the turn to MES 2 attitude, but all systems continue to operate well. And Centaur has begun 4S settling, and it's also begun to despin from its PTC roll. And Centaur has completed its despin from the PTC roll, and it is continuing to reorient to its MES 2 attitude. And Centaur has now achieved its MES 2 attitude. Just about 2 minutes to MES 2. And Centaur has begun the pressurization sequence in the fuel and oxidizer tanks for MES 2. Tank pressures look good. One minute to MES 2.
That is the restart of the Centaur. For a second burn that will last about 9 minutes.
We have fuel pre-start. Oxidizer pre-start. We have ignition and full thrust on the RL-10. This is an expected 9-minute and 3-second burn. Centaur PU is now in closed loop control. RL10 chamber pressures look very good. Turbine inlet temperatures as expected for the set mixture ratio. And we are seeing hydrazine burn-off occur, increasing upper stage performance. Centaur PU continues to command an oxidizer-rich condition. PU mass error is approximately 250 pounds. RL10 continues to perform very well. LOX pump discharge pressures, fuel vent inlet pressures are within expected parameters. PU is now commanding a slightly more nominal mixture ratio as the mass error is being reduced towards 0. Centaur continues to have hydrazine burn-off sequences occurring. Signatures look good. And the burn-off phase has been completed. Centaur is currently accelerating at 0.69 Gs. Data quality remains good. Engine operation is as expected. Hydrazine line temperatures are reading bottle temperatures as well. It's nominal for that system. Five minutes remain in this 9-minute burn. And Centaur PU is now operating at nominal mixture ratios as the mass error is reduced to 0. And we continue to see our normal hydrazine thermal conditioning cycles. Signatures are typical. PUs continuing to operate near nominal mixed ratio. Engine performance remains very good. Three minutes to MECO. Centaur is continuing to accelerate, now currently at 0.95 Gs. Two minutes to MECO. One minute to MECO. RL10 continues to perform well. Centaur PU error is 0, now controlling at nominal mixed ratio. Coming up on MECO momentarily. Engine continues to operate well. And we have engine shutdown. Shutdown looks good. 4S settling is begun. And Centaur has begun its turn to spacecraft separation attitude. Coast phase between MECO and spacecraft separation is scheduled at 3 minutes and 15 seconds. Centaur tank pressures are stable, bottle pressures look good. Bus and battery voltages are stable as well.
Everyone here in the Launch Control Center now awaiting spacecraft separation. Centaur reorienting
RLA
for spacecraft separation.
57.3, DLA 19.6, basically right where we plan to be. Centaur is now settling at 50% duty cycle. And Centaur has completed its turn to spacecraft separation attitude. Prior to separation, Centaur will spin up the spacecraft at 8.4 degrees per second.
And we're less than a minute away from spacecraft separation.
And Centaur has begun the spin up of the spacecraft for separation.
LCSC.
Centaur has achieved spin rate, and we have spacecraft separation. This concludes the plus count commentary for the AV-29 JUNO mission.
This is Atlas Launch Control. We'll be standing by now for a short interview with Omar Baez, the NASA Launch Director for today's countdown. The official liftoff time was 12:25:00.146. That was first motion of the Atlas off the pad at Complex 41, 12:25:00.146. And at this time, we have every indication that we've had a very successful flight of the Atlas V, Atlas Centaur rocket, and that JUNO is now on its way to Jupiter. And at this time, we do expect to have a post-launch news conference at about 2.5 hours after the launch, so that would put it at about 3 o'clock. And at that briefing, we'll find out the actual state of health of the JUNO spacecraft. This is Atlas Launch Control. We're now 56 minutes 35 seconds after the launch of the Atlas V rocket. And joining us here in the Atlas Spaceflight Operations Center is Omar Baez. Omar was our NASA launch director for today's flight. And Omar would like, first of all, to tell us your assessment of how the flight so far looks.
Flight so far looks fantastic, George. The spacecraft did separate. It's in in the right orbit to head to Juno or start its journey to Juno.
Jupiter.
Jupiter. Excuse me. The excitement got me there. And yes, we are right on track for that, and everything looked good.
The last part of the countdown was a little interesting, and maybe you could explain more in layman's terms what was actually going on there that pushed us out while we looked at this issue.
Yeah, we had an issue with one of our helium bottle charging circuits that started to cycle quite a bit. Cycling means that it's trying to charge our onboard bottles to maintain pressure. Well, it turned out we isolated it to a leak on the ground side. The flight bottle was fine. We had the proper mass to do all our control actuations that we need in flight from those bottles. So we isolated it to the ground system. There was some additional questions, and it drove us to start consuming some of the window. And we ended up consuming roughly 51 minutes of our window there.
Now tell us why that system is important. Why was the launch team concerned?
Well, that system basically controls the pneumatic functions of the Centaur. In other words, if we're gimbling the engine or shutting off valves or energizing valves, this is a pneumatic system that not only provides that pressure but also helps in pressurizing the tanks and keeping the tank pressures up. So it's how we store our helium commodity on board.
Well, it appears, Omar, that with a good flight underway, there's another Atlas right on the heels of this. What's about to come out to Complex 41?
Well, we're going to have our Atlas and Centaur vehicle for the MSL mission, which we're launching in November.
Mm-hmm.
And we're looking forward to getting that work done. But before we do that one, we have Grill coming up inside of a month here, and work on that mission is ongoing right now at Complex 17. And as soon as we're done with that, we shift gears back to the West Coast to do the NOAA or the NPP mission at Slick 2. On a Delta II before we get back to MSL.
Vandenberg. So this is quite a year of high profile profile missions for us. So, well, Omar, it's good to be able to congratulate you and the NASA and United Launch Alliance team, because this appears to have gone very well for everybody, and I'm sure that very shortly we'll hear some very ecstatic remarks from Scott Bolton, our principal investigator. So, Omar, thank you very much, and we'll look forward also to talking with you when we get to Mars Science Laboratory.
Okay, George. Appreciate it.
And that will conclude our launch broadcast for Juno. We're now at 1 hour, 32 seconds, 1 hour, 0 minutes, 32 seconds from the launch of Juno, now on its way to planet Jupiter. This is Jupiter Launch Control.